Chapter 8.6, the intersection of non-linear systems. Intersection of non-linear systems. So the goal is to graph the functions give the solution of the point or points of intersection. So we're going to look at a few examples of how to do this. Okay, one, I'm taking this one from my MATLAB. Y is equal to x squared plus 3 and y is equal to x plus 3. Given the system y is equal to x squared plus 3 and y is equal to x plus 3, graph and solve. So we recognize that the first equation, y is equal to x squared plus 3, is a parabola. A parabola with the vertex on the y-axis and shifted up 3 places. So we know that when x is equal to 0, y is equal to 3, and we can plot that point. And then we pick a point to the right and a point to the left. Say when x is equal to 2, y is equal to 2 squared plus 3, which is 7. So 2 and 7 would be a point. And then since that point at 0 and 3 is the vertex, we just go 2 points to the left of the axis of symmetry at -2 and 7. Okay, because when x is equal to -2, y is equal to -2 squared plus 3, and it's still 7. And from this, we can go ahead and sketch our graph for this part of it. Okay, now the second equation is a straight line, y is equal to x plus 3, and we simply graph this using intercepts. Okay, when x is equal to 0, y is equal to 3. When y is equal to 0, x is equal to -3. Okay, so we take those two intercepts. When x is equal to 0, y is equal to 3. And when x is equal to -3, y is equal to 0, we put a straight line through those 2 points, and we have our second graph. Now, the points of intersection of this graph is the solution to it. And sometimes we can't see where those points of intersection are, okay? But we know that it intersects at 3, 0, and 3, and at at it looks like, I don't know, 5 and 2. So what we're going to do first, we're going to do a couple of things. First, I want to make sure that you know how to graph this in my MATLAB. So here's our graph, and you would want to use the parabola tool, touch 3, then touch 2 and 7, and then 2 and -7. And then for the straight line, you simply touch the 2 points, -3 and 0. Okay. So my parabola looks okay, and you want to perhaps open it out and look at it. -3 and 0, save. And if it's not correct, it's going to tell you that it's not correct. But in this case, we have a correct graph, yeah? So we're going to go ahead and copy that graph into our notes as well. This is from the homework. Now, we have to give the solution to this graph where the points intersect. And you've got two ways to do this. You can do the calculator method. And it looks like the intersection is at, I would say that the intersection occurs at, solution is at what looks like 0 and 3. And the next one looks like it's at 5 and 1. Okay? From the graph. But we want to verify this with the calculator first. So I would go ahead and put these two graphs into the calculator. Y equals to, say, x squared plus 3, and y is equal to x plus 3. So we should see a graph that is very similar. My window is out of whack. So my window is not in a normal zoom. So press the zoom and select number 6, zoom standard. So this should look vaguely like the graph that we have, yeah? All right, so to find the points of intersection on this graph, we press second, the trace button, and select number 5, intersect. To get the first intersection that's, we think at 0 and 3, press the enter button 3 times. Okay, so it's going to do its best job to give you that intersection. Now, if you want to be sure, you can say, clear it again and trace it. And then do the process again. Second, calculate, intersect, enter, enter, enter. And, it's giving you a number that's close to the intersection, which is at 0 and 3. Then to get the second point, we move it up there. Second, somewhere close to the intersection. Calculate, intersect, enter, enter, enter. And it gives us the second intersection as 1 and 4. So I thought that I had the second intersection as 1 and 5. We go ahead and take it as 1 and 4. Okay. It is 1 and 4, yeah, 1 and 4. So this is not 5 and 1, but 1 and 4. And x is equal to 1, y is equal to 4. And if you want to check to see if the answer is correct, you just go ahead and type it into the MyMATLAB part of the homework. Okay. Use your okay, so I'm going to use the tool here. I don't know if this is going to work. Yeah, 1. And how do I move forward on this? 4. This is annoying to type with this program. Let me put it back on my keyboard so I can use the keyboard to type it in. Yeah. Okay. Close parenthesis. And then type in your second intersection point, which is 0 and 3. Okay. And check the answer. So the calculator is convinced that this is the correct answer. We can go ahead and put that in our notes as the correct answer. Yeah. Now you're probably asking, well, is there an algebraic way to get the answers for this? Yes, there is. Algebraically, to find the intersection points algebraically, set the two equations equal to each other. Set x squared plus 3 equal to x plus 3. Because at the points of intersection, the two equations are equal to each other. And if you solve this, we have x squared minus x the 3's would cancel out, is equal to 0. And factor would give x into x minus 1 to give x is equal to 0 and x is equal to 1. Okay, so the two solutions, when x is equal to 0, y is equal to 0 plus 3. So one solution is 0 and 3. And when x is equal to 1, y is equal to 1 plus 3, which is equal to 4. So the second solution is 1 and 4. So I gave you 3 ways to get the answer. You can trust the graph, you can use the calculator, or you can find the answer algebraically. All right, now we're going to next look at two different types of equation. Let's look, say, at a system y is equal to 5 times the square root of x, and y is equal to 6 minus x. So this system here, this is the square root of x. This means that x has to be a number that is greater than 0, because we can't find the square root of a negative number. Okay, so I'm going to go right ahead and construct this graph with my calculator. Five square root x, and then my second equation is 6 minus x, and graph them. So I see that this graph, the intersection point is isolated in the first quadrant. So I'm going to go to the window and take out the negative value of x and the negative limit of y to get a better picture of the graph, yeah? And then we see this. This is our graph. Uh-oh, I think I did something wrong here. Let's go back to that window. Oh yeah, y minimum is 0. Y maximum is 10. Yeah, I mixed those two up. 0, the minimum is 0, and the maximum is 10. And graph it. So now we should see a nice graph. And it's asking us where that intersection point is. Okay, so it looks like it's at 1 and 5, but we're going to ask the calculator to figure it out for a second. Calculate intersect. So move the spider until you can see it. Okay, you have to move that spider until you can actually bring it into view. And it's not showing up yet. So go backwards on the x values. Maybe we can see it soon. We need to be able to see that spider somewhere near the intersection point. It's coming. There it is. Okay. Okay, so it doesn't have to be exact. And then hit the enter button 3 times. Enter, enter, enter. And it's telling us the intersection is at 1 and 5. Okay, the first graph is our square root. Y is equal to 5 square root of x. And the second graph is y is equal to 6 minus x. As you can see, it's a negative slope graph with intercepts at 6 and 6. Okay. Algebraically, if you wanted to find the answer, so the solution is 1 and 5. Now, algebraically, you can do this as setting the two equations equal to each other. So 5 square root x is equal to 6 minus x. And this is a lot of work to do this, right? Square both sides. We have 25x is equal to 6 minus x squared. Okay, if you square both sides, so 6 minus x squared, if you do FOIL on that, would be x squared minus 12x plus 36. And then if we take away 25 from both sides, you would have x squared minus 37x plus 36 is equal to 0. So factoring here, I would have x minus 36 and x minus 1 is equal to 0. So x is equal to 36 and x is equal to 1. But we know that this intersection point is close to 1. So we were going to take x is equal to 1 and take this one out. Okay? So when x is equal to 1, we can just substitute into one of the equations. When x is equal to 1, y is equal to 6 minus 1, which is equal to 5. And that would give you a solution as 1 and 5. This should have only one solution because it's a square root graph. So it wouldn't it wouldn't intersect a straight line in more than one places. Okay. And you have to know how to graph this question with your calculator, because the question is going to give you a series of graphs and ask you to pick out the correct graph. But you already know what a square root graph looks like, so it's kind of easy to pick out the intersection, and then to just type in your answer for the solution. This one intersects at 1 and 2. Okay. All right, let's go ahead and put this graph in, because we need to get this one out of the way. All right, so we're going to go ahead and copy this problem, which is x squared plus 5, graph it with our calculator, and then solve it. Yeah. So this is question 3. The first graph is y is equal to x squared plus 5. So when x is equal to 0, y is equal to 5. And then we need 2 points, perhaps 1 on the left or 2 on the left and 2 on the right. So when x is equal to 2, y is equal to 2 squared plus 5, which is 9. When x is equal to 2, y is equal to 9. And then y is equal to, when x is equal to negative 2, y is also equal to 9, and sketch your graph. Okay, so and then the second part of this is y is equal to negative 4x plus 1. So you can do this with intercepts. When x is equal to 0, y is equal to 1. When x is equal to 0, y is equal to 1. And this is a negative slope graph, so you need a point on the left. So how about when x is equal to, say, perhaps negative 2, y is equal to negative 4 times negative 2 plus 1, which is equal to 9. So we have negative 2 and 9. We're going to mark that negative 2 and 9 is right up here. And if you put a line here, it kind of shows you a really close intersection point that you can't get with the calculator. And I'm going to go ahead and graph this with the in my MATLAB to make sure that we can graph this. So the first equation is at 5 and 0, then 9 and 2. And then 9 and 2 and -9 right there. Okay. I'm not really sure about how that looks. Let's go ahead and clear it and start over. We have 5 and 0. 1, 2, 2 and 9, and then 1, 2, 2 and -9. Yep. I think that's close enough. I hope I drew that 2 and -9. 1, 2, 3, 4, and then 1, 2, 3, 4. Okay, we'll take it as that. If there's anything, we'll come back and do it. And then we said that the line occurs at 1, and then the second point was at 9. Yeah, 9. 9 and 2, right there. All right, this is a really, really close graph. It came out okay, but now you can see how difficult it is to get the intersection point from this graph. So I'm also going to go ahead and put this into the calculator to try to get my answer from that. Yeah. It looks like it's intersecting at 2 and 9, but let's go ahead and put it into the calculator. Yes. So calculator, y is equal to x squared plus 5, and y is equal to minus 4x plus 1. Zoom back to a standard window first. And we want to ask the calculator the intersection of that point. So second, calculate the intersect. Now, because that point, we move that spider somewhere close to the intersection point and hit the enter button 3 times. Enter, enter, enter. And the calculator is going to make its best attempt to give you the intersection as 2 and 9. Okay, it's going to come as close as it possibly can to the answer. So the calculator's solution is at 2 and 9. Sorry, -2 and 9. -2 and 9, yes. -2 and 9. Now, algebraically, you can calculate it using algebra by setting the two equations equal to each other. We have x squared plus 5 is equal to -4x plus 1. So x squared plus 4x plus 4 is equal to 0. And factor this, we have x plus 2 is equal to 0. So we only have one value for x. X is equal to -2. And y is equal to -4 times -2 plus 1, which is equal to 9. So you can get that answer algebraically also. All right, the final type of problem that I want to discuss with you is purely an algebra problem. We have to solve the system y squared plus 7x plus x squared minus 2x minus 8 is equal to 0. The second system is, this is 7y, sorry, 7. The second system is y plus 7 plus 2x minus 8 over y is equal to 0. So some things, notice y cannot equal to 0, because if y were 0, we would be dividing by 0, yes? All right, now look at these two equations. And to kind of fix what's happening here, we have to eliminate the y on the denominator. So we're going to multiply this whole equation by y. So let's write back our first equation, y squared plus 7y plus x squared minus 2x minus 8 is equal to 0. And then distribute y to the second equation. Y times y is y squared. So at this point, I notice that I can eliminate y squared by multiplying by negative y instead. Yeah, multiplying by negative y. So negative y times positive y is negative y squared. Then 7 times negative y is negative 7y. And then negative y would cancel out with y on the denominator, and the signs would change, okay, because we would have 2x minus 8 over y times negative y, which would cancel out. So this would be negative 2x plus 8. Is equal to 0. And if we added these two equations, this would go away, this would go away, this would go away, and we would be left with x squared minus 4x is equal to 0. Which if we factor it, we would have x into x minus 4 is equal to 0. So x is equal to 0 and x is equal to 4. So we want to go ahead and make these substitutions first into the first equation. Let's substitute x is equal to 0 in the first equation. We have y squared plus 7y plus 0 squared minus 2 times 0 minus 8 is equal to 0. Okay, so this is y squared plus 7y minus 8 is equal to 0. Factoring, I have y plus 8, y minus 1 is equal to 0. So y is equal to negative 8 and y is equal to positive 1. So far we've got a solution. When x is equal to 0, y is equal to negative 8. Okay. When x is equal to 0, again, y is equal to 1. So now let's test the second value, substitute 4. So y squared plus 7y plus 4 squared minus 2 times 4 minus 8 is equal to 0. So this is y squared plus 7y, 4 4s is 16 plus 16 my substitution 2 4s minus 8 is equal to 0, sorry. So this cancels out here. This is positive 16 minus 16 is equal to 0. Yep. So this is 7 into, sorry, y. We factor out y here. Y into y plus 7 is equal to 0. So y is equal to 0 and y is equal to 7. So we know from the start that y cannot equal to 0. So this answer can't be here. The only other answer is y is equal to 7. So when x is equal to 4, y is equal to 7. Now this graph is one of those that you cannot do with the TI-84. You would have to do it with, say, Desmos graphing. I'm going to graph it for you and show you the graph of it. So I would go to the Desmos program, Desmos graphing. And the reason you have to use Desmos here is because the TI-84 can only graph when you set y equal to something. In this particular case, you can just simply type in what you want to graph, and it will graph it for you. So y squared plus 7y plus x squared minus 2x minus 8 equals to 0. And we see that this is essentially a circle. Now our second graph will be y plus 7 plus 2x minus 8 divided by y equals to 0. And here you can see Desmos does a wonderful job. It shows you one solution is at 0 and 1, 0 and negative 8, which we solve 0 and 1, 0 and negative 8. And then one solution at 4 and 0, and the other one is at so this one here, the 4 and 0 one, does not exist because y cannot be 0. So right there, I'm going to do a snap of this graph and bring it over to the notes so you can have it. Okay, let's put that in our notes. Okay, so to demonstrate what we have on this graph for our answer, we can see that the points do exist. Right here we have the first solution, which is at 0 and 1. Our second solution is at 0 and negative 8. Our third solution is at, I'm sorry, this is 4 and, negative 7, negative 7, negative 7, my bad. 4 and negative 7. And this solution here does not exist because y cannot equal to 0. Okay, y cannot equal to 0. So that solution doesn't exist. All right.